Hi everyone, welcome to Xinhua Live. I'm Liang Xizhi with China Xinhua News Agency. I'm now at the China National Offshore Oil Corporation, or CNOOC's NPIN 51 platform. This is Asia's largest offshore oil production platform. It is located in the Pearl River mouth basin in the South China Sea. As the treasure for mankind, ocean provides oil, natural gas, and other fossil energy. It could also help us recycle carbon emissions, contributing to the sustainable development of human society. Today, China's first offshore carbon dioxide storage demonstration project was put into operation at NPIN 51 platform, with an annual storage capacity of 300,000 tons, a total of more than 1.5 million tons, equivalent to planting nearly 14 million trees, filling in a void in the country's offshore carbon dioxide storage technology. Where I'm standing right now is the main deck of the NPIN 51 platform. With our camera, you could see the ocean around us and other parts of the platform. Now I'm joined by Deng Chenghui, project manager of CNOOC's NPIN 51 project. Hi, Mr. Deng. Could you please tell us how offshore carbon dioxide reinjection wells will work in the platform?
Okay, the rejection well is a grid channel between the oil production platform and the subsea formation. Unlike a conventional oil and gas production well, which extracts oil and gas resources from the ground to the surface, a rejection well separates the high carbon dioxide from the associated gas during the oil production process and inject it back into the ground. Through reinjection, carbon dioxide from the ground was reinjected back into the ground.
Okay, could you explain to us briefly how carbon dioxide will be injected into the seabed?
This is similar to pumping a pump with a pump. The answer is applying pressure. First, the carbon dioxide has to be processed at the platform to reach a supercritical state between gas and liquid. Why to make carbon dioxide supercritical? That's because carbon dioxide is in the supercritical state has very good mobility. It is more active. So after we apply pressure to inject it into the ground, it will find its own place all by itself. When carbon dioxide is injected into the ground, initially most of them will move to the top of bowl and form the gas cap. Meanwhile, some part of the carbon dioxide will be captured in the pores of the ground. Some slowly dissolve in groundwater, and some form minerals after reacting with rocks and groundwater. Over time, there would be less and less free carbon dioxide because more and more carbon dioxide will be dissolved, captured, and sequestrated through mineralization.
Okay, thank you, Mr. Deng. Now we are going downstairs to the lower decks. The weather is very pleasant today, and you can enjoy the ocean views through our camera. Now we are coming for the so-called Christmas tree of the carbon dioxide reinjection well. The carbon dioxide associated with oil field development will be captured, separated, pressurized to the supercritical state of gas-liquid mixture. And will be injected into the dome through a green channel on the seabed, achieving long-term stable storage. So, Mr. Deng, here will be the injection well and the so-called Christmas tree of the well. Could you briefly introduce to us how the well works and what's the path of the well?
Okay. This is Christmas tree, and this is gas injection Christmas tree, and here this is master valve, and this is a swing valve. The pressure is 5,000 per square inch.
Yes, we can see a red ribbon. Now it's bonded on the injection well to celebrate today's put into operation. So today is really a big day for the injection well to be put into operation. What do you think of it?
Okay. First, the gas will come from here, and then through here, and then from here and to the well.
Okay. Thank you very much. Now let's watch an animation video to see how the injection well works. And now we are going to the next point, the central control room.
Deep in the thousands of meters underground rock formation, there are not only precious oil and gas resources, but also greenhouse gases such as carbon dioxide. During the process of drilling for oil and gas, these gases will be emitted into the atmosphere, exacerbating the greenhouse effect. We must inject the captured carbon dioxide underground through engineering techniques, allowing it to travel back. What can we do to take them home? Firstly, it is necessary to find a suitable storage location. Experts from CNOOC have found a geological structure resembling a giant bowl that seems to be upside down underground. It has large storage capacity and strong sealing ability, which can stably cover carbon dioxide for a long time. After selecting the location, a channel for transporting carbon dioxide into the giant bowl needs to be established through drilling. The giant bowl is approximately 3 kilometers away from the Yingping 15-1 platform, 800 meters under the seabed. Based on this calculation, it is necessary to drill an extended ridge well with a vertical depth of 894 meters and a horizontal displacement exceeding 3,000 meters. Such a large horizontal displacement doubles the friction force of the borehole wall, making it very easy to get stuck during drilling. Moreover, the shallow soil at the bottom of the well is soft, just like soft tofu blocks. During the drilling process, the borehole is prone to collapse and leak drilling fluid. The difficulty of drilling this type of well can be imagined. In order to achieve significant horizontal displacement, drilling experts from CNOOC have customized a batch of special weapons. Not only can tailor-made drilling fluid resist acidic carbon dioxide corrosion, it also supports borehole wall and lubricates well bore, ensuring smooth and unobstructed drilling. The first tailor-made carbon dioxide corrosion-resistant cementing slurry produced domestically ensures that well bore is unbreakable like titanium during decades of injection. Last but not least, Offshore oil experts innovatively install optical fiber monitoring devices onto gas injection string with a monitoring point every other meter, just like thousands of sharp eyes, observing whether there is any leak in the gas injection string thousands of meters underground without blind spot.
Where I'm standing right now is the central control room of the NPIN 51 platform. Through our camera, you can see all the operation scenes of the platform. Now I'm joined by Mr. Xi Xiaohu, Deputy General Manager of CNOOC's NPIN platform. Hello, Mr. Xi. Could you please tell us what the carbon dioxide storage demonstration project on the NPIN 51 platform is about?
Okay, right now we are at the NPIN 50-1 platform, an important oil drilling platform in China. The offshore carbon dioxide reinjection well on this platform has been officially put into operation, which makes the opening of the China's subsea carbon dioxide storage. Not long ago, we joined the carbon dioxide rejection well inject the carbon dioxide associated with oil extraction into dome-like geological structure. At a water depth of nearly 900 meters, the geological structure is like a giant ball on the ground, forming a huge subsea carbon can that can steadily trap carbon dioxide.
Thank you, Mr. Xi. Now you can see through our camera the screens of the monitoring system of the control room. The engineers are closely monitoring the system to see if anything is wrong in the platform. We can see through the screens the details of every part of the platform. Now, let's watch another 3D animation video to see more closely how the offshore carbon dioxide reinjection well works. And now we'll be going through the lower decks to the fishing decks of the platform. Now we are about to reach the fishing decks of the Enping 51 platform. The platform, equipped with China's first offshore carbon dioxide storage device, will inject and seal up carbon dioxide generated during oil and gas exploitation into the seabed on a scale. This is of great significance for China to achieve its goals of carbon peak and carbon neutrality. Mr. Xu, what does offshore carbon dioxide sequestration mean for China and the world?
If the cumulative sequestration of Enping 50-1 projected eventually reaches 1.5 million tons, then the carbon dioxide emission reduction could be equivalent to planting nearly 14 million trees or taking nearly 1 million cars off the road. It could be a terrific demonstration project for environmental protection and carbon emission reduction. By the end of 2022, China has carried about 100 CCUS projects with an annual carbon dioxide capture capacity of over 4 million tons, an increase of 33% compared to 2021. Xinhua is also accelerating its offshore whole chain CCUS technological research and its offshore demonstration project construction. Enping 50-1 project is equipped with the technological systems and equipment for offshore carbon dioxide capture and storage, laying a good foundation for carbon capture onshore and storage offshore, and large-scale carbon dioxide sequestration offshore. CCUS as a global recognized large-scale carbon reduction technology will help global society to achieve the goal of carbon neutrality. According to the International Energy Agency, CCUS is expected to contribute to about 14% of carbon dioxide emission reduction by 2050. It is also a promising prospect for market application.
Thank you very much, Mr. Xi. Now we can see through the camera the many wells of the Enping 51 platform, especially the green injection well. So, after visiting the Enping 51 platform, we know better how the platform injects and seals up the carbon dioxide generated during the oil and gas exploitation. It has achieved an important breakthrough in the field of offshore carbon dioxide sequestration and explored a new way for China and even the whole world to achieve the carbon peak and carbon neutrality. Now we are about to wrap up today's Xinhua's Live. Thank you for watching and see you next time.